Hey everyone, I just wanted to welcome you to my presentation on data structures and algorithms and wanted to walk through you just a few of the different types of data structures and their implementation. So let's go ahead and get started. First off, we're going to cover queues, then we're going to cover sets, and then we'll follow up with the trees. So jumping into queues real quick, what you can see with queues are they basically are a data structure that follows the principle of first in, first out. So what you can think of with that is, for example, if you're in line at the store, looking to check out, say you've bought some fruit at the grocery store, you usually end up getting in a line or a queue. The first person in the queue is the first person to go through the checkout line, and so on and so forth. So, what we can take a look at here are some of the operations that are done with the queue. You either will be appending items to a list or a deck, and then you'll be dequeuing items. So, either using the queue.pop feature, or if you're using deck, it would be queue.pot left. And these are in Python. So on the screen here, what you'll see is an example of a queue. Just simple basic structure. You would declare a queue here as a list, and then we can loop over each item in the list to add a new item. And then when we go to do uh, queue.pop here, we can then do operations on tasks as long as the length of the queue is greater than 0. So using a list will give you a complexity of O of n in big O notation for this, just because of the fact that it does have to go over each item of the list. Whereas if you're using deck, your on queue and dequeuing is done at O of 1 complexity, because it's just adding a new element onto the end without having to add any additional work to the list. And when you dequeue, it just removes the first element of the list and doesn't have to shuffle the subsequent elements forward in the list in order for the dequeuing to occur again the next time you need to perform an operation in dequeue. Moving on from there, we're going to go ahead and start talking about sets. Sets is just an unordered collection of unique elements, which means you can only have one element appear once in a set, and they usually store and manipulate distinct elements. So some of the common operations you'll see are union, intersection, difference, and membership. The first three, union, intersection, and difference, will run at O of n complexity. And then the membership will run at O of 1 complexity. And so with that, we'll go ahead and take a look at just some basic sets. And if you'll notice, we have some of the different operations happening on here. And then all we're doing is checking for membership of whether or not the element that we're looking for is in set 1 or not. And so that's your basic functionality through sets. Now, from here, we'll go ahead and move on and talk about trees. The tree data structure is hierarchical, and it has nodes that are connected by edges. Each tree starts with a root, and then each node, except for the root, has a parent node and 0 or more than one child node. Some of the important terminology to remember is root, which is the top node of the tree, a parent, which is a node that has one or more child nodes, a child, which is a node directly connected to another node when moving away from the root, and then a leaf is a node with no children. And the fifth one is a subtree, which is a tree rooted at a node within the main tree. Um, One of the more common structures are binary trees. They're a specific tree where each node can have no more than two children, which is either a left or a right child. And you can have full binary trees, complete trees, or balanced binary trees. And so, what we're going to look at here is just the implementation of a binary tree in Python, and uh, you'll see is we'll use recursion to go through it and find out um, which information is in each node. So as we go through, we're going to be traversing through the tree and moving down to either the left or the right node. And then once we hit the end of the tree, we'll be able to see the value and that it's the root of the tree. In these different operations, there most of the cases for the tree operations run at O of n complexity. The average cases for deletion, searching a binary tree, or inserting into a binary tree run at O log of n, mainly because you can determine at each node whether you're going to the left node or the right node based on the value that's in that node, which gives you the ability to go to one side or the other. So going through all of those here, that's just a recap of the three data types that we looked at. That's queues, sets, and trees. And as aspiring computer scientists and programmers, getting a hold of the data structures and algorithms is extremely important, mainly because these concepts are the backbone of efficient problem solving and our organization of programs. As long as we can understand, organize, manipulate, and traverse data, we can achieve better performance and scalability in our programs. So, although it may seem like a daunting topic to cover and to learn, it is something that will help you in the long run as you continue to practice and learn more about how data structures are implemented and used in day to day programming. Thanks so much for being here with me and learning about this, and hope to talk to you again soon.